So we want to find the radius of convergence and the interval of convergence of the series. So again, we can use the ratio test. It's an alternating series, so we'll pay attention to those absolute values. We've got the limit, we've got the absolute value, we've got -3 n plus 1, x to the n plus 1 over the square root of n plus 1 plus 1, or n plus 2, times the square root of n plus 1 over -3 to the n, x to the n. Okay, we'll do the thing that we do, try to simplify it, try to rewrite it. We've got the limit, absolute value, -3 to the n times -3 to the first, x to the n times x to the first, the square root of n plus 1, over square root of n plus 2, -3 to the n, x to the n. Now, -3 to the n, cancel, x to the n's, cancel. And we've got our limit. -3 and x, I'm going to write those out front. -3x. Oh, it's positive now because I took the absolute value, times the square root of n plus 1 over the square root of n plus 2. So I want to find this limit. You could probably guess what this limit is. It's going to be 3 times the x. I guess x probably needs an absolute value since it could be either positive or negative. The 3 doesn't need the absolute value anymore because we took the absolute value of the -3, so it's okay there. We've done enough of these problems. Have we done enough of these problems to recognize that this limit is going to be 1? If not, we can multiply by 1 over root of n over 1 over root of n, and then we will have the limit as n approaches infinity of 3 times the absolute value of x times the square root, and I'm going to write it all under 1 square root, 1 plus 1 over n over 1 plus 2 over n. And these go to 0 as n approaches infinity, so all that works out to be 1, just as we expected. So what we have is the limit is 3 times the absolute value of x, which we want to keep smaller than 1. So that means we've got from -1, 3x, positive 1. That inequality there. Dividing both sides by 3 gives me -1/3 to 1/3. And now, at this point, we still need to check the endpoints. So the first question was, what's the radius of convergence? So the radius of convergence is 1/3. So what about when x equals -1/3? What does our summation become? So we have the sum of -3 to the n, 1/3 to the n, -1/3 to the n, the square root of n plus 1. So what is this? Can we simplify this? Well, that looks like the negatives are going to cancel each other out when we do this. I think I will write it out. How's this? Negative 1 to the n times 3 to the n times negative 1 to the n times 1/3 to the n, so that you can see the negatives cancel out. Okay, so we've got positives. 3 to the n times 1/3 to the n is just 1. And we are looking at the sum of 1 over the square root of n plus 1. Now, we know that this term right here is smaller than this term right here. Since the denominator has a bigger number in the denominator, that means the fraction becomes smaller. So we're using the comparison test, comparing the thing that we don't know with the thing that we do know. And the thing that we do know is this is a p equals 1/2, so a divergent p series. So I'm going to put an x here because it's divergent. Divergent when x is negative 1/3. What about when x is positive 1/3? Well, it's all going to work out to be the same type of thing, except now the only difference is that negative. So what we're going to end up with is the sum of negative 1 to the n times 3 to the n times a 1/3 to the n over square root of n plus 1. So this n to the third and the n to the 1/3 will cancel out. Now, when I look at this, I see the sum of a negative 1 to the n over the square root of n plus 1. And if you have done your homework, you will recognize this as an alternating series, since the signs alternate, and this is a decreasing, positive decreasing function. We know this converges. So there you have it. The radius of convergence is 1/3. The interval is from negative 1/3 to positive 1/3, where we can exclude negative 1/3 but include positive 1/3.